Position of hydrogen in periodic table. In this module, you will learn about the position of hydrogen in the periodic table. You must be familiar with the table shown here. It is the modern periodic table. As you can notice, hydrogen is not placed in any of the groups. Rather, it has been given a separate position. In order to understand the reason behind its separate positioning in the periodic table, we need to study about hydrogen in detail. The atomic number of hydrogen is 1, so it has only one electron and one proton, and its electronic configuration is written as 1s1. Its electronic configuration is similar to that of group 1 elements or alkali metals. The general valence electronic configuration of alkali metals is also ns1. Hydrogen can lose its only electron to form a unipositive ion, that is, hydrogen ion. In the similar manner, alkali metals also lose their valence electron to form unipositive ions. For example, the sodium atom loses its valence electron to form a sodium ion, and the potassium atom loses its valence electron to form a potassium ion. Because of the ability to lose an electron to form unipositive ion, hydrogen and alkali metals also resemble each other in their chemical properties. For example, with oxygen, an alkali metal combines to form its oxide. Similarly, hydrogen combines with oxygen to form hydrogen oxide, that is water. Similarly, an alkali metal combines with chlorine to form its chloride. Also, hydrogen combines with chlorine to form hydrogen chloride, that is hydrochloric acid. In the similar manner, with sulfur, an alkali metal forms its sulfide and hydrogen forms hydrogen sulfide. So, hydrogen shows a lot of similarities with alkali metals in its chemical properties. However, it is still not placed with the alkali metals in group 1. It is due to some of its dissimilarities with these elements. For example, alkali metals are solids at room temperature, whereas hydrogen is a gas at room temperature. Another difference is there in the ionization enthalpies of the alkali metals and hydrogen. The ionization enthalpy of all alkali metals lie between approximately 400 kJ per mole to 520 kJ per mole, whereas the ionization enthalpy of hydrogen is 1312 kJ per mole, which is much higher than alkali metals. Due to these dissimilarities, hydrogen is not placed with the alkali metals in group 1. Let us check another possibility of positioning of hydrogen in the periodic table. As already mentioned, its configuration is 1s1, so it has one electron less than the stable gas configuration. So it can gain one electron to form hydride ion. This property is similar to the halogens that have electronic configuration of ns2, np5, and thus have a tendency to gain one electron to form halide ions. Not only this, hydrogen has some other similarities with halogens too. For example, halogens generally exist as diatomic molecules due to the formation of the covalent bond between two halogen atoms. Similar is the case with hydrogen. It exists as H2, in which two atoms of hydrogen are combined through the covalent bond. Another similarity is that halogens combine with alkali metals to form metal halides. Also, hydrogen combines with the alkali metals to form metal hydrides. Another similarity is in their ionization enthalpies. As we have already seen, the hydrogen has a high ionization enthalpy, which is quite comparable to the ionization enthalpy of the halogens. So, looking at the similarities between halogens and hydrogen, hydrogen can be placed with a group of halogens, that is 17. But Due to some of its dissimilarities with halogens, hydrogen is not placed with halogens in group 17. The main difference between hydrogen and halogen is of size. Hydrogen is one of the smallest elements, whereas the size of halogens is quite large. Moreover, hydrogen can both lose and gain an electron and thus can form both negative and positive ions. On the other hand, halogens can only gain and can thus form only negative ions. Therefore, hydrogen cannot be placed with the halogens in group 17 too. So we have seen that hydrogen has a unique nature, so it can't be placed with either alkali metals or halogens. Other than that, the positive ion of hydrogen has exceptionally small size as compared to the size of any other ion. This fact further supports the unique nature of hydrogen and its unique position in the periodic table. Let's recap. Hydrogen is given a separate position in the periodic table and is not placed in any of the groups. Hydrogen shows some similarities with the elements of the two groups, Group 1, that are alkali metals, and Group 17, that are halogens. However, some dissimilarities of hydrogen with the elements of both Group 1 and 17 led to the separate positioning of hydrogen in the periodic table.